Okay, the next topic, nonlinear systems. Now you did 2x2 linear systems, lines, 3x3 linear systems. They're not lines, but they're kind of like lines. And then we did circles. Now, circle is not a line. Nonlinear, meaning not a line. So I'm going to show you what the heck you're going to be doing. Okay. I drew you a parabola and a line. You said nonlinear. You said not lines. You can have a line, but a parabola is not linear. Parabola is not a line. A circle is not a line. So here I drew a parabola getting smacked into by a line. Notice that it meets twice. Here I have a parabola and a circle. Now, I could get cute with these. I could make it so if I had drawn the parabola down here, I could make it hit 4 times. If I had the parabola bottoming out here, I'd have it hit 3 times. So these equations are going to get kind of nuts. They could hit twice. They could hit 3 times. They can hit 4 times. You don't know until you do the question how many answers you're going to get. So these are kind of nutty, these graphs. You do not have to make pictures. I want to emphasize this. You're not going to be doing this. You're not drawing pictures. You're going to have equations. So I'm going to work 2 examples and show you how to do them. Then I'm going to write you a little summary of what I did. Alrighty, first example. The top equation, you don't have to worry about this, is a parabola. The bottom one is a line. They might meet once, they might meet twice. I don't know. Now, when I look at this equation, there's going to be 2 techniques that you're going to use. The first thing you're going to try when you do these is what you did with the 2x2 and 3x3 systems. You're going to try doing elimination by addition. Now, in this case, it's going to work. Because if I do positive y, take away y, they're going to cross out. Now the question is what happens here. I need to add these straight up and down. Is x squared plus x 2x squared? Maybe it's 3x squared. Maybe it's x cubed. You can't do ridiculously stupid things here. X squared and x are not the same creature, so you can't add them. So when I add straight up and down here, I'm going to get x squared plus x. The y, take away y, crosses out. The equal sign still makes a bigger equal sign. Make sure you're doing the math right. 11, you're doing negative 5 plus 11. That's 6. Eliminate y. All right, you do elimination. Now I'm going to subtract the 6 over. I'm going to factor. Let's see. X and x. Let's see. I'm going to put this sign first. This one has to be the opposite. 6 and 1. 6 take away 1 is not 1. So I guess it's got to be 3 and 2. So this tells me that x plus 3 equals 0. Or x minus 2 equals 0. So I get x is negative 3. And I get x is 2. Yay! I'm all done! That was so easy. Yeah. You have x and y. You're not done. Oh, son of a gun. So you got to pick one of these 2 to go back and plug in x and figure out what y is. And it's entirely up to you. Let's use the top one just for fun. All right, so like I said, I'm going to use the top equation to figure out what y is. I used elimination by addition to eliminate y. I got a quadratic equation, which I set equal to 0 and factored, and I got my 2 x's. Now I'm going to plug them in one at a time. When x is negative 3, I get a 9 there. Oh man, that's a big number. Don't let it make you think you did it wrong. So this is one of the points these graphs meet at. What? This craziness. Now plug 2 in there. I need to extend my squiggle. Subtract 4. So there's my second point where they meet. Wow, that's craziness. You could check. I'm going to show you the check. but I'm going to write it first and then show you. So here's me checking. I used the top one to determine what x was. Excuse me, I said that all wrong. I used the top one to plug in x and determine what y was. Okay, so I already knew x. I used the top one to figure out what the y values were when x is -3 and x is 2. So I got those 2 points where this graphs supposedly meet. So then I took the bottom equation and I'm plugging in. I got x is -3, y is -14. Be careful here. Y is -14, so you're taking away a -14, so you get a +14 there. If you screw up your signs, you're going to think you did this wrong. So be very careful. So that one works. Then I got x is 2, y is -9. Again, negative is positive, so you get 11 equals 11 in both. So these are the 2 points that the graphs meet. You figure them out without doing the graphs. That's the whole point. You're doing these algebraically. You are never going to draw these pictures and try to figure out where they meet. It would be ridiculous and impractical. Okay, so that's the first example. Now I'm going to do a much, much harder one. All right, so the previous example was, shall we say, a little trivial. I mean, it's not super easy, but this one is much more complex. Now, if you look at it, you have x squared plus y squared equals 17. This is a circle whose radius is radical 17. Yeah, good luck with that. You can't even draw this circle, okay? The bottom one is a line. So I have a circle and a line. I'm guessing they're going to meet twice. They might not. Now, if I start trying to add these up and down, I hope you're noticing that elimination is not going to work here. There is no way you can add these together and eliminate x or y. I have x squared x, y squared y. Nothing's going to eliminate. So what you have to do here is you have to do a substitution. I'm going to solve the bottom one for one of the letters and replace it in the top one. Now, I'm going to solve for y. You don't have to. I'm going to solve for y. That's what y is equal to. Subtract the x over. Y is 5 minus x. Now I'm going to go back to the top. Wherever the y was, this is the top equation. I just replaced the y with a big-ass parentheses. I'm going to put this there because that's what y is equal to. There was a y there. I'm going to put 5 minus x there. Whew, this is already getting hard. Now, be very careful. This is easy. It's 25 plus x squared. 25 plus x squared. 25 plus x squared. I don't think that's what that's equal to. I don't think so. Maybe I'm wrong. Well, I'm not wrong. 5 times 5 is 25, and negative x is positive x squared. But you got to do the middles and the end, right? You got to make your rainbow. Come on, make the rainbow. So when you multiply this out, you get 25. Don't try to reverse this. Leave it like it is. Don't try to get cute and write x minus 5. It's not the same thing. Okay? So you get 25. Take away 5x, take away 5x is minus 10x. And then negative x is positive x squared. Boy, this is so hard. So, yes, it is hard, but you got to be careful. Now, I have to combine my like terms. I have an x squared and an x squared. It's x to the 4! No, it's not. 1x squared and 1x squared is 2x squareds. Minus 10x plus 25 equals 17. What the hell am I supposed to do now? I think you should probably set it equal to 0 and hope that this thing factors. So let's see. Subtract 17. I told you this one was much harder. 25 take away 17 is positive 8. Now you can factor it. Oh, wait a second. I have 2, 10, 8. I think you want to divide everything by 2 first. So why don't you just divide everything by 2? Ah, okay. Nice. So I'm going to continue it on the other side. I'm going to factor it. Now I'm going to keep editing these because when I'm writing on this side, I tend to block the camera and I don't want to block too much. Now, this sign goes first. I have a positive here. that either meant I had plus plus or minus minus. So this sign must be a minus. Now, to multiply to 4, you either have 2 and 2 or 4 and 1. 2 and 2 is not going to make a 5. So you got to do 4 and 1. So I'm going to cut to the chase here. You get x equal 4. You get x equal 1. Whatever shall I do now? Whatever should I do? I don't know what to do now. I can't figure it out. It's so complicated. Yeah, it can be. Look, you already have y equals 5 take away x, and you just figured out what the two x's are. So just put them in there. Put x equals 4. And now put 1. Well, I see some symmetry here. You get x is 4, y is 1. You get x is 1, y is 4. Freaky. So, you get those points. I'm just going to check one of them for fun. They're both the same number, so it doesn't matter. X is 4, y is 1. 4 squared is 16, not 8. 1 squared is 1. And I'm pretty sure 16 plus 1 is 17. So, yay, it works. So, this problem is a lot more complicated and nasty. I mean, I did it kind of quick because the steps go kind of quick, but elimination doesn't work here. I had to do substitution. I had to take the bottom one, solve it for y. Now, you could have solved it for x. All right? You could pick either letter you want, but in this case, just for convenience, I solved for y because I'm used to having x's. So I solved for y, subtracted x. I plugged it back into the top one. That's called substitution. I multiplied it out. I rearranged the terms in the way that I'm used to seeing them. I divided out the 2. I don't want to try to factor that with that 2 there. Everything was even, so I was able to just divide it all by 2. I just cut the numbers in half. Half of 2 is 1. Half of negative 10 is negative 5. Half of 8 is 4. Then I was able to factor it, get my 2 x's, plug them back into my very convenient equation that was already sitting there waiting. The nice thing about this is when you get to that step, you will already have the equation to solve for the other letter just waiting there for you. So you can just plug the numbers into that and boom, there you go. Okay? Now, there aren't really a list of steps I could write. I mean, because they vary depending on the problem that you get. But you're basically solving by either using elimination or using substitution. So I'm going to write 2 examples. So there are the 2 examples. I'm not going to work them for you, but I'm going to walk you through the beginnings of them. So look, x squared, y squared. Perfect candidate for elimination. The problem is that, I could multiply this bottom one by 3 and eliminate x squared, but then I have to times this by 3. I don't want to do that. How about I just switch all the signs? You can't do that. Sure I can. I can multiply it by negative 1. Negative 1 times this, negative 1 times this, negative 1 times this. They all switch. Now, well. If I add them together now, what happens? Y squareds cross out. 1x squared and 3x squareds is 4x squareds. Equal signs get bigger, right? Equal sign, 24 is 76, 100. Divide by 4. You get x squared is 25. Take the square root. You get plus or minus 5. I'm not finishing for you. That's your job. You finish it. I just showed the beginning of it. That this one is elimination. Easier. Elimination is always, always easier. Now, look at the second one. Oh, boy. X squared, x. Y squared, y. Crap. Elimination's not going to work here. You don't have the same thing. You don't have y squared, y squared. If this was a negative y squared, it'd be over. I'd add them together. But it's not. So I have to do substitution. Now, I'm going to be slick about this. I don't want to solve for y this time. I'd have to subtract x from both sides, but I have a negative here. I'm going to solve for x this time. You see what happens when I add y to both sides? You get x equal positive y, take away 3. See how much easier it was to solve for x this time? You don't always just mindlessly solve for y. Sometimes it's easier for you to solve for x. And now I'm going to replace x with y minus 3. So wherever I see x, I'm going to put y minus 3. Now I multiply this out. Y squared minus 6y plus 9, blah, 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 blah. And you continue from there. All right, so this is substitution. Elimination, substitution. There's nothing else to say. I wish I could give you a list of concrete steps to follow, but there aren't. You either eliminate or you substitute. And then you just use the regular rules of solving. Here, I'm going to divide by 4 and take the square root of both sides. Here, I'm going to end up having to factor. It all depends on the type of question that you get. So even at the end, it's not always the same thing that you're going to do. Okay? So these problems can be pretty nasty, especially these. So you got to really take your time to do these. Watch your signs, make sure you combine your like terms correctly, and blah, 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 blah. So I will wish you good luck doing the problems.